All right, here we are back at 6.2 doing confidence intervals for means, and I'm going to try to work through a couple of examples here. So, in a survey, 18 people were asked how much they spent on their child's last birthday gift. So, that's a little code here for telling us our sample size is 18. The results were roughly bell-shaped with a mean of 43, X bar, $43, and a standard deviation of $5. So these are the results of the 18 people being surveyed. So that's how we know it's a sample. That's how we know we have X bar and we have S. Find the margin of error at a 98% confidence level. So here's my confidence level, making that 98% a decimal. So we need to find our critical value and we need to find our standard error, and the product of those will be our margin of error, similar to what we were doing before. So I need to find alpha. Alpha is 1 minus our confidence level. And then I like to figure out the tail area, so that's alpha over 2, because we're putting the confidence interval, breaking it up into two pieces. So I'm going to take alpha and divide it by 2. And now I have a t-distribution. If I want to draw a little picture of what this represents, kind of like a normal distribution. So I've got a little tail area of 1% here and 1% here, and I'm looking to find this value along the way. So my confidence is this 99% here in the middle, and I've got, it was 98%. I was going to say, I knew these were 0.01 in each tail. So just like our normal distribution, those add to 1. So my t, alpha over 2, is going to be this score right here. And that's the critical value. So I'm going to go ahead and find that. Not with the pointer though. So I'll call it the critical value. It is our t alpha over 2. And since it is a t thing here, and I have kind of a probability, so I'm looking for an area, I'm going to use this t inverse. And my probability is going to be 1 minus this right tail area. And my degrees of freedom, I forgot to do this here. It's actually going to be n minus 1. So, did the degrees of freedom here. I didn't write them up above this time. You're more than welcome to write them up above. And here, showing my work here. So in this case, since I wrote the n and I did not write the degrees of freedom, I had to find, subtract 1 from my sample size here to get the degrees of freedom. So this is my critical value. Next up is the standard error. And these formulas are on your formula sheet. It's going to be quite useful now. The standard error is going to be sigma, s, the sample standard deviation, divided by the square root of n. Now I would encourage you, if you're typing all the values into Excel, to just start clicking on the cells because it's much, much quicker. Now we were looking for a margin of error. That's actually abbreviated E. Sometimes I do M of E. And it's the product of our critical value and our standard error. And I'm going to encourage you to just let Excel do all the work. Save the rounding for the end here. So give our answer to 2 places. So 2 decimal places, excuse me. 3.025. So that 2 is going to round up to a 3. And there we go. So we have some of these where they just give us the variables right there. Now we're looking to find an actual interval, and here we'll have the low side and the high side. So maybe I'll just do this one next, right here. 99% confidence. So n, a little space here, is 30. X bar, and they're kind of using our notation for us, so this is working out pretty nicely. S, 14. Our confidence level is 99%. The question detail keeps showing up here. Alpha is going to be equal to 1 minus this. And really over here, we could add our degrees of freedom. It's going to be equal to n minus 1. We know we're going to want that eventually, and we can either find it here or there. But it is another piece of information that you let me know if you write it. So alpha over 2 can be this tail area. We take our alpha and divide it by 2. Now, if I draw a little picture here, I've got this guy, here's 0. Somewhere over here, this is going to have an area of 0.005. And so this is my T alpha over 2, or my critical value. To actually figure out what that is, to calculate it, whoops, I've got T inverse, and I'll do 1 minus that little tail area, and then my degrees of freedom, which I calculated up here. And if you want to skip the step of calculating the degrees of freedom, just go ahead and use n minus 1 right there. It won't hurt anybody's feelings, hopefully. So now our standard error. Our standard error is equal to the sample standard deviation divided by the square root of n. And then our margin of error is the product of our critical value and our standard error. And then we need a lower limit and an upper limit. I forgot to show my work right here. Grab these real quick. Just the two of them. So the mean is our best guess estimate here. So we do the mean x bar minus the margin of error. This gets us our low side. And if I want to be a little lazy here, I can copy this and then just edit this to a plus. So I have the mean plus the margin of error here. If you don't want to be lazy, you can just grab the mean and add the margin of error, and it'll get you to the same spot. So then when I go over here to 1 decimal place, the lower limit is 31.95. So if I'm going to 1 decimal place, the 5 makes the 9 go up to a 10. So this makes this 32.0. And then the upper 46.45, so 46.0 there. And there we've got it. So I think I'm going to pause here. Quick little recap. We did a couple of questions. We found the critical value once, and then we found the margin, we found the margin of error again, and then we used the margin of error and the mean to find the lower and upper limits here. So get our information. Again, this is going to be kind of important for you as we're getting a lot of things that we're learning. Make sure you write down the correct variable, what it means over here. Work through your work. I know people don't like drawing the pictures, but I really encourage you to draw the pictures. It helps with understanding what you're doing and connecting the concepts. Find our critical value, the T inverse, where we used to use our normal standard inverse. We're here, getting the area to the left of it. Our degrees of freedom. Our standard error is our standard deviation divided by the square root of our sample size. And this is our sample standard deviation. If we had a population one, we'd be using a normal distribution. Anyway, make the product of these to find our error, subtract the error from the mean to find the lower limit, add the error to the mean to find the upper limit.